Thank you so much, Shannon, for the opportunity to speak on your channel today. So in this video, I will introduce you to the functions of the tidyverse in R programming. More precisely, we will first download a dataset online. Then we will import this dataset using the readr package of the tidyverse. Afterwards, we will manipulate this dataset using dplyr. And then last but not least, we will visualize this dataset using the famous ggplot2 package in R. So without too much talk, let's jump right into the R code. As a very first step, we have to install and load the packages of the tidyverse, as you can see in lines 3 and 4 of the code. I have installed these packages already, so for that reason I'm just going to load them with line 4 of the code. So after running this line of code, all functions of the tidyverse are imported in RStudio, and we can now use them in our session. As a next step, we have to download the dataset that we want to use in our example. And in this video, I will use a dataset downloaded from Kaggle, which is about data science jobs and salaries in 2024. You will find a link to this dataset in the description of this video. However, on this page, you can download the dataset as you can see here. And then you have to store the downloaded file in a file location path, as you can see here. So in this case, I have located the file in the directory Dropbox Yogg datasets, and the file is called data science job listings. Now, if we want to import this dataset to RStudio, we first have to specify the file location path. And as you have seen, this dataset is located in this folder. So for that reason, I specify a data object containing this file location path as a character string in a new data object. So after running line 6 of the code, you can see at the top right of RStudio that a new data object called myPath is created. And this data object contains our file location path. In the next step, we will use the function read_csv, which is provided by the readr package. Readr is one package of the tidyverse, which is used for importing data into R programming. And we combine this function with the stringr function, which is provided by the stringr package. That's another package of the tidyverse. And the stringr function combines our path that we have specified before in line 6 of the code with the file name of our dataset. And then I'm storing the output of this in a new data object that is called myData. So after running lines 8 and 9 of the code, you can see that at the top right of RStudio, a new data set called myData is appearing. We can also have a look at this dataset by clicking on the myData name of our dataset at the top right of RStudio. So after clicking here, you can see that a new window is opened, which is showing the structure of our data. So as you can see, our data contains 500 rows, and the column names position, job title, which is the name of the job, company name, the location of the job, the salary range, a date where the salary range was estimated, the logo of the company, and a link to the job as well as a company rating. Now in this analysis, we are interested in only two of those columns, namely location, so where the job is located, as well as the salary. And for that reason, we perform a first data manipulation step using the dplyr package of the tidyverse. And from this package, we apply the select function, as you can see in lines 12 and 13 of the code. And we apply this function to our data set. We do this by using a pipe operator. So the pipe operator specifies that the function that is used afterwards is applied to the data that is specified before the pipe operator. And then we are storing the output of this in a new data object, which is again called myData. And since this data object has the same name, we are overwriting our previous data set. So in other words, our dataset myData is updated after applying the select function. And as you can see within the select function, we specify that we want to keep only the column names location and salary. So after running lines 11 to 13 of the code, our data set is updated, and you can see that by clicking on the data set at the top right once again. Then this window is opened again, and you can see our updated data set, which contains only the location and salary columns. In the next step, I also want to rename the column names of our data set because I want to work with lowercase letters as column names. And for that reason, I specify that I want to rename the column name location with an uppercase L to the new column name location with a lowercase l, and the same for salary. And to do this, I use the rename function, which is also provided by the dplyr package. And as you can see, the remaining syntax is similar to the syntax in lines 11 to 13. The only difference is that we use a different function in which we have to specify different arguments. So after running lines 15 to 17 of the code, our data set is updated once again. So now you can see that the column names are in lowercase. As a next step, I want to replace certain values in our salary column by an A, because if you have a closer look at this column, you can see that most of the values are salary ranges. However, some of these values are per hour. And I want to remove all these values from our data set because I want to work only with the rows where we have yearly salary estimates and not only salary estimates per hour. And for that reason, I specify that I want to replace all values in our column salary, which contain the words per hour or the character string per hour, by an A. And we do that by applying the str_detect function, as you can see here. So first we are detecting each value in salary which contains this character string. And then we apply the if-else function to specify that every time when this is detected, we replace this value by an A. And then we specify that we want to assign these values to the salary column. So in other words, we are overwriting or updating the salary column. And we can do that using the mutate function, which is also provided by the dplyr package, as you can see in line 20. So after running lines 19 and 20 of the code, our data is updated once again. So as you can see now, the values where we had hourly estimates instead of yearly estimates have been replaced by an A. In the next step, I also want to extract the numbers of these ranges, and I want to calculate the mean value of these ranges because I want to convert the salary column to a numeric column. And we can do that, as you can see in lines 22 to 25 of the code. So in these lines of code, I first specify the mutate function. So the mutate function is used once again to update our salary column, as we already did in line 20 of the code. However, within the mutate function, we specify this time that we want to use the str_extract all function. We use this function to extract only the values in our ranges. Then in the next step, we use the map function to convert these range values into numeric values. And then we use the map double function in combination with the mean function to calculate the mean value of this range. And then we replace the previous values in salary by this new output. So after running these lines of code, you can see that our data is updated once again. And now we have converted the salary column into a numeric column, which contains the mean values of our ranges. Now, in the next step, I also want to remove the rows which contain NA values in the salary column, and we can do that using the drop NA function, as you can see in lines 27 and 28 of the code. Once again, we use a similar syntax, so we replace our previous data object myData, and we use the pipe operator to apply the drop NA function to our data object myData. So after running these lines of code, our data is updated once again. And now you can see that we have removed all rows with NA values. And you can also see that our data set now contains less rows, because before it contained 500 rows and now only 381 rows are remaining. So we removed 119 rows from our data set. So until now, we have modified the salary column. However, I also want to modify the location column, because as you can see currently, the location column contains the city and the state of this city. And I want to analyze our data based on the states only. And for that reason, I want to remove the cities from our location column. And we can do that, as you can see, in lines 30 and 31 of the code. So once again, we use the mutate function. However, this time we replace the location column, and we specify using the sub function that we want to keep only the values after the comma in this column. So in this case, only the states. So after running these lines of code, you can see that our data is updated once again, and now the location column contains only the states. If you have a closer look at this column, you can see that we also have values which tell us that these people work remotely. And you also have other rows which contain the value United States. So for some of these rows, the specific location was not specified in the data set. And I also want to remove these rows because I want to analyze only the rows in our data set where we actually know the location. Remote is also fine. I also want to compare remote workers with people that work in certain states, but I want to remove these rows which contain United States. So as a next step, I use the filter function, and the filter function can be used to filter certain rows in our data set. And as I have explained before, I want to keep only those locations which are unequal to the character string United States. So after running lines 33 and 34 of the code, our data set is updated once again. And as you can see, there are no United States values anymore. You can also see that now our data contains only 370 rows instead of the 500 rows in the beginning. By the way, if you would like to learn more about R programming, data manipulation, dplyr, and the tidyverse, you might take a look at the courses at Statistics Globe, because soon we will start a new course on data manipulation in R programming using dplyr and the tidyverse. You will find a link to this course in the description of this video. And now let's move on with this video. So at this point, we can move on from the data manipulation to the data visualization part. And for data visualization, we use the ggplot2 package, which is a very popular package, and in my opinion, the best package for data visualization that exists. And in the following part of this video, we will draw different plots using the ggplot2 package. So one advantage of the ggplot2 package is that it integrates seamlessly with other tidyverse packages, such as dplyr. So as you can see, we can use it in combination with the pipe operator that we already used for our data manipulation tasks before. And in this case, we specify that we want to draw the values in our dataset myData. Then we use the pipe operator, and then we apply certain ggplot2 functions such as ggplot, as, and geom_density. And we apply these functions as the dplyr functions before by specifying the pipe operator, and the ggplot functions are added on top of each other using the plus operator. So the ggplot2 package follows a so-called layered approach. And in this case, I want to draw a density plot of our salary column. For that reason, I specify within the ggplot function that the x values should be equal to our salary column. And in order to draw a density plot, I add the geom_density layer on top. So after running lines 36 to 38 of the code, you can see at the bottom right of RStudio that a density plot is appearing, which is showing the distribution of the salaries in our dataset. And as you can see, the peak of our density is at around 100,000 US dollar. However, you can also see that there's a smaller peak at the right side of the density, which shows that there's a group of very highly paid people. You have already seen in the data manipulation part of this video that the syntax of the tidyverse is always very similar. And for that reason, we can also use a similar syntax to draw different types of plots using the ggplot2 package. So for instance, in the next example, I want to draw a box plot of our data. And the only thing that I have to change is that I use the geom_boxplot function instead of the geom_density function. So lines 36 and 37 of the code are exactly the same as lines 40 and 41. So after running these lines of code, you can see that another graph is appearing at the bottom right, which is this time showing a box plot of our entire salary column. Now we can modify our code to create more advanced graphics. So in the next step, I want to draw a grouped box plot. And I want to group these boxes based on our location column. And we can do that, as you can see, in lines 44 to 47 of the code. And the only thing that I change in this part of the code is that I specify the fill argument. And I specify that this argument should be equal to our location column. And we can run this code to see how this changes our graph at the bottom right. So after running these lines of code, you can see that a much more detailed graph is appearing. You can also click the zoom button to enlarge this graph. So after clicking this, you can see that we have created a graph which contains a separate box for each of the states in our dataset. However, you can also see that some boxes are very small. So these boxes contain only one observation because for some states we have only very few observations. And for that reason, in the next step, I want to perform an additional data manipulation step before drawing our graph. More precisely, I want to filter all locations where we have at least 10 observations. So what I want to show you here is that you can also combine data manipulation steps with data visualization steps. So as you can see, this part of the code is exactly the same as this part of the code. And this part is exactly the same as this part of the code. However, in lines 50 to 52, we specify additional data manipulation steps, and we do this all in the same pipe. So in these lines, I first group our data by the location column. Then I count the number of occurrences in each location, and I filter that I want to keep only those locations where we have at least 10 observations. And then afterwards, I ungroup our data. And then I specify the ggplot functions that we already used before. So after running lines 49 to 55 of the code, you can see that another box plot is appearing at the bottom right. We can enlarge this box plot by clicking on the zoom button. And then you can see that we have filtered for those locations where we have at least 10 observations. So we have less boxes in our group box plot. And you can also see that these boxes are more meaningful because they contain more observations. Now, this graph is still difficult to read because we still have many different states available. And for that reason, I also want to sort these data to visualize a sorted box plot. And we can do that, as you can see, in lines 57 to 64 of the code. And this code is basically exactly the same as the previous code that we have used in the previous example. However, there's only one additional line, which is line 61. And in this line, we use the mutate function and the fact reorder function to reorder the location column based on the medians in the salary column. So if we do that, you can see that our graph is updated. And as you can see now, we have ordered our graph by median values. So in this graph, you can see that the highest median salary is paid in DC and the lowest median salary is paid in MD. Of course, our data is limited, so I'm not sure if this reflects the real salary distributions in the entire population, but based on this data set, we can draw this conclusion. Now, in the last step of this video, I also want to modify our graph because I want to add a title to our graph. I want to remove the label on the x-axis. I want to remove the legend title, and I want to remove the values on the y-axis. And once again, this is exactly the same as the previous example, and then we add further layers to this graph to modify it. So after running these lines of code, you can see that our graph is updated once again. So after clicking on the zoom button, you can see that now we have added a main title, data science salary by states in thousands. We have removed the y-axis values. We have removed the axis label on the x-axis, and we have removed the title of the legend. So now you could, of course, dive deeper into the functions of the ggplot2 package and the tidyverse to modify these data and the graph in even more detail, but I hope that I was already able to demonstrate the strength of the tidyverse in R programming. Thanks again for the opportunity to speak on this channel, and make sure to check out the video description of this video because there you will find a link to the more comprehensive course at Statistics Globe on the topic data manipulation in R programming using dplyr and the tidyverse. You will find the code of this video and you will find further information about this topic. Thanks again and see you soon. Bye bye.